Hey there, Emmanuel here from Web Dev Fuel and welcome back to the Web Dev Fuel channel. Now in today's video we are going to learn exactly how to build a to-do list application using Svelte and Go. Now both of these technologies are really interesting and really powerful, and that stems from their simplicity. Now usually when you think about when we as developers actually think about a powerful tool for us to develop web applications, we think of something that comes with everything pre-built and everything done for us. So think of something like Ruby on Rails usually, or when we're talking about something for the front end, usually React, or even something that comes with more stuff given to us already pre-built, so we can go ahead and build applications. Now, in the last couple of weeks, I've been playing around with Go, and with Go actually for a longer time, and with Svelte for the last couple of weeks, and I've been really enjoying the experience of building applications, and I think that both of these technologies put together are really powerful, and again, because of their simplicity. Now, in today's video, again, we're going to go over how to build a to-do list application, and by the end of it, you're going to have the ability to create new to-dos, to delete them, and to rename all of your to-dos. Now, with that being said, let's go ahead and first of all set up our backend. So we're going to start by setting up our backend with Golang, and then we're going to move to the front end so we can actually see all the changes in our browser. So first of all, let's go ahead and create here a new folder, and I'm going to call this one Snappy To Do, for example, because this is going to be a fast application, not only on the front end, but also on the back end. And then let's go ahead and cd into this project folder. And in order to initialize a new Go project, it is actually very simple. All you need to do is type go mod init, and then after that you want to go ahead and type usually what happens inside of the Golang community is people go ahead and type simply the path to the GitHub project, and if this folder in particular is nested within that project, we usually append that path to this URL. So in my case, I'm going to type in here github.com/EmmanuelTourist, and then I'm going to type in here Snappy To Do. And because this is the backend, I'm going to simply go ahead and type in here backend. Now, to make sure that this all works, and I almost forgot it, I'm first of all going to type in here make the backend so we can create a backend folder. And just like I told you, instead of simply typing in here github.com/EmmanuelTourist Snappy To Do, I'm actually going to append in here backend just to make this more clear. Now, with this done, let's also go ahead and initialize our Git project repository. Actually, I'm not going to, for now, make any commits, but in the future, if you need, actually go ahead, do this, and also push this to a remote origin in order to make sure that you do not lose any of your progress. Now let's go ahead and come back here to our backend. And now inside of our backend, we need to go ahead and start by installing the technology that's actually going to allow us to route requests to particular functions. Now, usually, again, what happens is that people go and grab something that comes pre-built, so with a lot of what people call usually batteries included. And usually inside of, let's say, inside of Ruby, it's Rails. Inside of Golang, I'm actually blanking on the name, but I'm pretty sure there's like a library that does all of most of stuff that you need for the backend for you. But instead of doing that, we're going to simply go ahead and do the following. We're going to use libraries that we need for particular things, and when we don't need, and what that's actually going to allow us is when we don't need something, we are actually not going to use it. So here's what I mean by that. So we're going to be using the CHI router, so she router, I'm not really sure how you spell it. And instead of having like an entire library that does the routing, that does all of the, let's say, Json encoding and decoding and all of that stuff, we're going to be using a library for the routing, and then we're going to handle all of that stuff by ourselves, because having a library that does stuff for us is actually overhead for us to be able. We need to make sure that we update it, we need to make sure that it doesn't have any bugs, and we need to learn a new technology each time that new stuff comes around the block. Now with Go, it is very simple. We simply put inside our project what we need, and then we build by ourselves the stuff that we can build, and then the project stays very stable, and we don't need to make a lot of changes to it over time. Now I know that this was a little bit a long explanation, but I just wanted to make sure that you got exactly why we're building the application in this way. Now let's go ahead, and with the project initialized, we can go ahead and first of all import here the router. So simply go ahead and type go get, then the flag is U, so we can update. So if we already have this one, but just leave it in there. And then you want to go ahead, type github.com, go she, and then CHI, and then v5. So we need to import the version 5 of this package. Okay, so now go ahead and type, and as you can see, this was added to our project. Now we can go ahead and touch here the main.go file, and this is the file that is going to be the entry point into our backend application. And now we can go ahead and open here our project. So we can open in here, and if we come here to our main.go file, as you can see, we have an empty file that we can start typing things inside of it. So first of all, in here, we're going to define our package, and inside of Golang, this is how we essentially separate our parts of the code into different, let's say, like modules, you can think of it. So essentially what happens in here is we need to define this package, that main, and then, for example, here inside of this folder tree, we would actually need to call to specify that the package is main for all the files in here. Now, if we went ahead and created a new folder, and you'll see in just a second, we need to give it a different name. But for now, this is going to be simply package main, and then we need to import a couple of things. First of all, let's go ahead and import net HTTP. Then we also want to go ahead and import here our router. So again, github.com, go she v5, and then the same thing. So I'm going to simply copy this and the middleware, and you'll see in just a second why I'm importing the middleware, because we essentially need to log our request. Now, in order to make sure that this works, first of all, let's create in here a function with the name main, which is how we do things in Golang. So we need to call this function main in order to make sure that this project starts in here. So this is the main function of this file. And then in here, we want to define a couple of things. First of all, let's create a new router, and we give it here the variable name of R. Then let's use here a middleware, and this is essentially a couple of middlewares that are very, very basic that she provides us to interact with our backend. And in here, we simply need to call the logger. As you can see, the logger is a middleware that logs the start and end of each request, and then with some useful data along. So essentially the time of the request, usually if you want, all that kind of good stuff. And then we're simply going to create in here an hello world. So again, we need to specify here r.get. So this is the method. So you can essentially the HTTP method. So get, post, patch, delete, all of that stuff. And then inside of here, if we take a look, we need to essentially specify the pattern and then the handler function. So the pattern is going to be this one. So essentially the root path of our server. And then the function is going to get, we need to pass two things. First of all, we need to pass here the HTTP response writer. So this one is called W, and then dub, and then here a pointer to the HTTP request. Now the difference between both of these is that this is simply, you can think of this as like simply a value, and this is a pointer to a value. Now that's something that's specific to more low-level languages. Usually if you started like me with JavaScript or that kind of stuff, let's say Python, this usually doesn't happen, but in this case we here only need the response writer, and in here we need the pointer to the request. So make sure that you add this star right over here before the type. So now in here, let's simply return an hello world message. So we need to type in here right. So the response writer, again, this is the essentially, this will provide to us this type, this this interface actually is going to provide us with methods that we can then use to interact with the response. So essentially to modify the response that is going to be sent to the client. So inside of here, we simply want to return a very simple string, which is going to say hello world. Okay, so now we still have one final thing to do, and actually, as you can see, it says here that this is potentially unused parameter. So let's simply do this, or actually like this, so this doesn't complain. And then we finally need to start our server. So we need a function that is going to essentially start up our server in order to make sure that this works. So simply go ahead and type in here listen and serve on localhost 9000. And now, as you can see, we also need to actually pass in here our router. And now this is all done. And now if we go ahead and move inside this folder, projects. Okay, so now if we move here inside our snappy to do folder, and then let's navigate to the backend. Now in here we can simply go ahead and run this. And now if we go to a new one and we simply curl here http localhost 9000, as you can see, we receive back an hello world message. So now this is it. We now have a server ready to go. So let's continue and go ahead essentially and create everything that we need in order to make sure that we can handle JSON requests. Now the first thing that we want to do is we want to go ahead and inside of here, still inside our main.go file, we want to create a JSON middleware function. And this function is going to take in here a HTTP handler, and then it is going to essentially return the same thing. So it is going to take an HTTP handler and return another one. So inside of here, let's type return http.handler func, and then this is going to take a function. And as you can see, I have in here Go please, which is the language server for Go. So this automatically completes for me. So in here, we're going to pass the exact same thing that we pass in most of our request functions, which is again response writer and a pointer to the request. So now inside of here, we want to simply set our header. So we need to use in here again the header method from the response writer interface. And then we want to set our content type. And the content type, if you're familiar with web requests, is going to be of application JSON. And this makes sure that our clients know that this response is a JSON response. And when we are making responses, let's say from Insomnia or Postman or simply for curl, this actually formats it in the correct way because it knows that it is a JSON file, a JSON response actually. And finally, we need to go ahead and serve our HTTP just like this. So we need to pass in here, as you can see, it says that we need to pass the response writer and a pointer to the request. So with this done, now let's move here to the top and we need to use this thing. So now if I go ahead and open in here Insomnia, as you can see, now if I go ahead and make a new request, let's say that I make a request again too, and actually we need to go ahead and first of all restart our server. So let's go ahead and stop the server and then restart it. And now if I go ahead and make again a request to localhost 9000, as you can see, it comes back here as hello world. and in the header, as you can see, the content type is of application JSON. Okay, so this was the most boring part of this whole video. So now we can actually go ahead and get into how to create our CRUD operations. So now the first thing that we want to do is we want to go ahead and simply create in here a tasks.json file. Now we could go ahead and actually connect this to a database, but this is besides the point of this whole tutorial. So I'm simply going to type in here a couple of tasks. So let's say that this one has the ID of 1, the name of wash the dishes, and done as false. Okay, so let's just put all of this in a new line. Okay, now let's go ahead and copy this, paste this in here, and you can go ahead and call this whatever you want. You can create different type of tasks, but these are basically going to be the default tasks that our application is going to have. So now in here, the number 3, let's call this one feed the cats, and finally let's call this one read a book. Okay, and let's going to make this like false true, so we can make sure that the application works correctly, because usually like if all of them are false, we are not aware if something goes wrong with the state of true inside of our application. So just to make this simple, let's keep it like this. This is formatting in a weird way, I'm not really sure why, but let's just simply keep it like this. And now let's go ahead and create our tasks. So first of all, let's create also a tasks file that is called tasks.go. And in here, just like I told you, the package is still main. Now we are creating in here, as you can see, a task.go file, but this package, because it is inside of this directory, still needs to be called main. And inside of here, let's start by creating first of all a type. And this type is essentially going to hold the structure of each one of our tasks. Now this is going to be very similar to this thing right over here, but we actually have a couple of different things. So first of all, the ID, which is going to be the task ID, is of type int. So it is an integer that we're going to increment each time that we create a new to-do. And then inside of here, we have, as you can see here, this backticks that essentially allows us to create a tag with information that we can pass to different kind of packages and to different kind of functions. So essentially this information is always going to be traveling with this type, with the task type. So inside of here, for this particular situation, what we want to use this as is to define what the JSON key is going to be, not only when decoding, so when we want to transform a JSON into Golang code, but also when encoding, so essentially when we want to create a JSON blob, a JSON string, a JSON blob from Golang code. So now inside of here also we need to type the name, which is going to be of string name, of key name JSON. So think of it like this: if we didn't go ahead and specify this here, the key would simply be like this, so all capital letters ID, and we don't want that, because this is usually how we how we type this inside of Golang, but inside of JSON it doesn't happen that way. And finally we have our done state, which is going to be of JSON done. So again, this is everything that we need to create a very basic task type essentially. So we have our ID, name, and done state. So now that we have our task type, let's go ahead and create a function that is going to get all of our tasks. So essentially we want to make a request and then get back an array with all of these tasks. So first of all, let's start by importing here io util. Then we need our log package and also net HTTP. So now let's go ahead and also define in here, so we can, let's define it right here. a constant. Now, usually when we work with JavaScript, and I mentioned JavaScript because most people nowadays start with JavaScript and then move over to different languages. Usually inside of JavaScript, a constant is something that we use actually inside of our code, but in Golang that doesn't usually happen. We actually define variables inside of our block function blocks, let's say, and then usually constants are things that we use across files or even across entire projects, and are usually things that are, like the same name says, constants. So for this thing, we're simply going to go ahead and type in here JSON file path, and this is because we don't want to all the time keep repeating where this test.json file is. So we're simply going to type this just like that. So as you can see, const, and then in here JSON file path, and then the string of tasks JSON. Now let's go ahead and create the function that is going to return to us our tasks. So again, in here the response writer, and then a pointer to the request. And now let's go ahead and decode the JSON file. Now for this particular situation, because we don't actually want, and I mentioned decoding, but I made a mistake. So because we are essentially going to, let's say we have in here our request, and then we have in here our response, and then we have in here our JSON file. So the JSON file, we have in here our request and then our response. Now, because we don't actually need to interact with any type of code, so let's say that we had in here some type of Golang code. So let's type in here Golang. If the flow would be like, let's go from the request to the JSON file, and then to the Golang code, and then to the response, we would actually need to add in here. So here, before we start actually interacting with this data, so more specifically inside our Golang code, and then before returning this to our response, we would have to do some type of decoding and encoding. So first of all, we would decode this from JSON to Golang code, so into types essentially. So we define here our types, and then we need to decode them, and then finally we would need to encode them. Now for this simple situation, we don't need to do that, and that's because we are going to essentially grab the file and give it back to the response directly. So that's why we're doing this way, and then as you can see in just a couple of minutes, we'll do it in a way that we actually need to first of all know if this data structure is what we need, then we can make changes to it, and then we return it back as a JSON file, as a JSON response. So with that in mind, let's go ahead and in here pass our JSON file, and in order to be able to read it, we're going to simply do the following. So io.util.read file, and then in here we're going to pass the JSON file path constant. Now what usually happens in Golang is that most functions that return an error, that potentially can have an error, they very specifically return that error, and we need to specifically handle. It doesn't happen in an automatic way. We don't, for example, try catch like in JavaScript. We don't have either like a, let's say, then and then a catch method inside of Golang. We do things more, let's say, we write everything more specifically. We don't like let things happen in the background that we are not aware what's happening. And I usually like it more this way because this is more specific. I know what's happening in the application, and this is what's happening here. Now, if you're more familiar with Golang, you already know what this is, but for people who are beginners to this and are not aware what this is essentially what this means. We essentially pass in here a function with the file name, and then as you can see, this is going to return an error if essentially if an error occurs while trying to read this file. So we need to handle first of all this error, and if the error is different than nil, and we actually need to pass in here the error, we're going to write here a header of HTTP status internal server error, and are also going to go ahead and print here an error with the message error reading tasks JSON file. And then in here we're simply making like a string interpolation, so we essentially pass in here this thing, and then the value that we're going to pass in here is going to essentially, so let's go back here to presentify. So essentially what happened is that this value is going to go from here to here, and Golang is going to insert this variable inside of our string so that we can then read the message and know exactly what's happening here. And we also need to return this block so that this function doesn't continue running. And if we have no error, so essentially the logic is if there's an error, so if the error is different from non-existing, from nil, we return this message, and if there's no error, we simply return in here our JSON file. So we're essentially writing data to the connection, as you can see, as part of the HTTP reply. So now we have in here our tasks function. So the next step is to add it to our router. So let's simply go in here and add our.get. So we're using the get method. The path is going to be tasks. And then instead of passing in here the function, we're simply going to pass in here tasks. And because this is part of the same package, we don't need to import this from a different package because it is the same one. So we can simply type in here tasks, and this already knows what this is. So we simply go to the definition. As you can see, this is the tasks. So now let's move back here. Let's go ahead and run the server. And if we go back here to Insomnia, we make the request, and as you can see, we have in here our tasks. Now let's just make an experiment so you can see what I mean by this. If we went ahead and let's say that we rename this to tasks1, so now this task.json doesn't exist, and if we went ahead and restart here the server and we made, as you can see, we simply would return, we would get back a 500 internal server error, and that's because this is what's happening in here. This is in actually handling the error and then returning just a status code. And if we move back to our terminal, so this is where we would be able to go ahead and debug this, we would receive in here, as you can see, error reading task JSON file, open tasks.json, no such file or directory. So this is why I think that Golang is very cool, because error handling is very, very simple. So now let's just go ahead and move this back to tasks.json, and let's continue with this video. Next, we want to go ahead and be able to create a new task and insert it inside of this JSON file. Again, if we were to use a database, this process would be a little bit more different, but for this purpose, let's just simply keep it simple and go ahead and create a struct, a new type struct that is going to essentially have the structure of our request, of our create task request. So let's go ahead and type in here create task. Let's call this one task body. This is a struct, and then this is going to have a string, which is again going to be of so again the tag is going to be JSON name. So this is essentially the same thing in here, but because we are creating a task and this is something more basic about web development, we don't need usually this data. We don't need the ID or the done state, because the done state is going to be false by default. Usually when we create a task, we could go ahead and add some kind of feature to like create a already done task, but usually inside of to-do list application that doesn't happen, and the ID is simply going to be incremented. So we're going to essentially grab the ID, the length of our list, and then we're going to essentially add +1 to that value, and then we can create our new task. So with that being said, let's go ahead and create in here a function called create task, and this again is going to receive the response writer, and we also need to pass in here the request, a pointer to our request. Now the first thing that we want to do is we want to define a new variable that's going to be called create body, and that is going to be of type create task body. So what this essentially means is that we want to create a new body, and then we want to decode our JSON file, and then pass this decode the body, and then pass all of the data from the body into this struct right over here. So let's go ahead and first of all type this way, so if error, and what this means I'm going to explain in just a second. I'm going to first of all type in here, so if there's an error with new decoder, so we're going to go ahead and decode this, and we're going to decode the request.body, and then we want to decode. So if the error is different than nil, we want to make something happen. Now here's exactly what this means. So what has essentially is happening here is that we are defining in here a function, and we are passing here a variable. So what's essentially happening is that instead of, for example, simply having like let's say in here we have an error that's returning here, and then we handle it on the next line. On this case, let's just clear all of this. In this case, what's happening is that we have essentially an error that is going to be returning here, and instead of handling on the next line, so this kind of syntax, let's say, we handle it in here. So what we mean by this is that we're going to run this entire function, and then if the error is different than nil, we're going to go inside of this block. If the function is nil, so if there's no error, we're going to continue running our code. So just to make sure that that is clear. So essentially what this means is that again inside of this block we want to go ahead and again handle an error. So let's simply go ahead and copy this. This is still going to be a started internal server error, and then the message is going to be error decoding body into struct, and we're going to simply pass in here our error. Okay, so now in here we essentially grabbed the request that the person gave us, so essentially the JSON that the person gave us, and we've decoded into a structure that Golang is able to understand. Now the next step is essentially to go ahead and read from the file. So let's go ahead and do the following. So os.open, and then we're going to pass in here JSON file path, and I've actually forgot to import, but I think if I just save this, as you can see, this went ahead and imported. We also need to import here OS, so we can open this file. And then again, if there was an error opening this file, we're simply going to go ahead, grab this, and paste this in here, because this is essentially the same error. Now we're using in here a different function, but this is essentially the same error. So if the file doesn't exist, if all that kind of stuff, this returns to us the error. And now actually let's go back here to the top, because I forgot something. So I just realized that this body here is declared but not used, and that's because we actually need to pass in here our value that we want to decode it into. So what's happening essentially is that this is grabbing a value, and then we want to point this to a value that this is going to decode it into. Now I'm again going to grab here this, and just to make sure that I explain this clear, because this is a bit different, and if you want to wrap your mind around it, it is a bit different than actually using normal code language. Now usually what would happen in here, let's say that we have a function in here, and then we want to return, let's say, something. So we're going to return in here this thing, and this is going to, let's say, going to be body and error. So if we had, let's say, this thing right over here, and then usually what happens is this. So essentially what happens with normal languages, with most of them, is that we pass something in here. So something happens here, and then this returns a value. Now, what happens with this kind of languages like Golang, like Rust, even C++, I'm not actually familiar with it, but with Golang and Rust, I'm more familiar. So what happens here is that we can pass actually values that are pointing to a variable and then modify that variable. So what's essentially going to happen is that we have to pass in here a pointer to the body, and then this is going to go ahead and modify this original value. So again, I just wanted to make that clear because Golang is a bit different than most languages. So we need to do it like this. And now again, what this means is that this value is going to be modified by this function. So let's go ahead and now continue with this. So we now need to go ahead and define here our tasks, which is going to be a list of tasks. So in JavaScript, this usually is an array. Inside of Golang, it is called a list because JavaScript's arrays are actually not arrays. But let's continue. So now in here, we need to simply go ahead and type if error. And again, this is the same syntax as you can see right over here. If error equals json.new decoder, and then inside of here we're going to pass the file, and then we're going to decode this into the tasks. And again, if there's any kind of error, we simply want to go ahead and return this, and this error is going to be called error decoding. Let's call this JSON file into struct. So again, now at this point we already have the request that the person sent us decoded. We also have in here our JSON file decoded. So now we can go ahead and modify these values so we can insert a new task into it. So let's go ahead and type in here new task, and then this is going to be of name body.name. Then again is going to be, just like I said, false, because by default this is always false. And the ID is going to be of length of tasks plus 1. So now this is essentially our new task, and now we want to insert this into this list, and then we want to encode, save the file, and then return this to our client. So let's go ahead and append this to our tasks. So what this essentially is going to do is that we have in here a list. So I'm going to make this like this because usually we think of it like an array. So we have here a bunch of values, and then we want to go ahead and append this here, which is going to be this new task right over here. So now let's go ahead and encode our new tasks. So instead of using this encode decode API, we're actually going to be using the JSON Marshal, which essentially makes the same thing. So the result ends up being the same. So let's say here J and error, the J is going to be the JSON, and we're going to type in here json.marshal, and then we want to marshal our tasks. Now if there's an error, so if the error is different than nil, you want to, again, let's go ahead and copy this, and this error is going to be called error marshalling tasks. So now that we have our JSON data, so as you can see here, it is essentially an array of bytes. We can go ahead and write this to our file, and then later we're going to simply return just the task that the person created, so we can then update it on the client. So let's go ahead and again error equals IO util.write file, and then we're going to write this to the JSON file path. So this is essentially going to overwrite the current data that we have, and we also need to pass in here the permissions. Now let's go ahead and handle this error. So if the error is different than nil, we want to pass in here an error, which is going to be error writing tasks JSON file. And now what we have at this moment is we already created, essentially overridden here our file with a new task underneath it. So you can think of it like, let's say 5 and then a different task in here with something and done as false. So this is what's going to happen after we run this request. Now with this done, let's go ahead and also encode marshal our new task. So if the error is different than nil, we want to go ahead and say that there's an error marshalling new task. And finally, we can go ahead and the header is going to be of status created, and we then go ahead and simply define it here. Now again, this is everything that we need in order to create our new task, but let's just go over one more thing, which is the following. If you go ahead and see here, this value was adding here a colon right before it. So essentially we have colon equals json.marshal, but in this case we only have equals. Now what's the reason for this? What this essentially means is that we usually inside, so this is essentially synthetic sugar for the following. So we could go ahead and do the following. So variable something equals 1, or we can go ahead and type something colon equals 1, and this is essentially the same thing. So this is the reason that we are doing this, and that is because when we define a variable inside of our code block, Golang doesn't allow us to recreate this variable because it already exists. So it simply goes ahead and rewrites it. So it essentially overwrites the data that this thing right over here holds. And because of this, because we have both of these are already existent in here, we simply need to pass in here the equal sign and not the colon equals. And if you take a look at here, it happens in also this case. So because we already have the tasks in here we simply need to pass the equal sign. So just that is also clear. That is how Golang works. So now we already have this thing done, so we can create tasks. And again, I know this is a bit long, but I want to make sure that I go over everything that you need in order to make sure that you understand everything that's happening inside this simple yet complex application if you look at it with the eyes of a beginner looking at Golang for the first time. Now let's go ahead and create a task. And actually, before I forget, we also need to go ahead and add this to our router. So let's go ahead and simply type in here or.post and then tasks, and then this is going to create a task. So now let's go ahead and restart the server. And now if you go ahead, let's see, the server is running. If we go ahead and send this like this, it is going to return an internal server because error decoding body into struct. So essentially because we haven't passed the correct body, it wasn't able to create. So now let's say that we want to finish this tutorial, and if we go ahead and press enter or send, as you can see, we now have a new task created. So essentially this returned to us the object with the ID of 5, name, finish this tutorial, and state false. And we should go ahead and see in here, now this is not formatted. Let's just go ahead and format this, and just like I said, the ID of 5, name, finish this tutorial, and then done false. Let's, for example, finish another tutorial, and as you can see, this is now of ID 6, and the same thing again happens here. We now see a new tasks inside of our JSON file. Okay, so next let's go ahead and update a task that is already existent inside of our JSON file. So the first thing that we want to do, similarly to the create task, similar to everything that we did with the create task, we first of all want to create a new type, which is going to be of update task body. And let's go over what we're going to need to add in here. First of all, we need to add a name with a pointer to a string. And I'm going to go over what that is in just a second. And then we also want to add in here a done value, which is going to be a pointer of boolean, and then this is going to be done. Now the reason we are creating in here this the reason this type is not simply of string but actually a pointer to a string is because, for example, we initialize here our create task body. So we're going to go ahead and, for example, initialize this. So this is going to be the body, and then this is going to be of create task body. Or actually, let's go ahead and do it like this. So this value right here is going to hold this value. So this struct is actually going to hold this value, which is going to be of name, and the string is going to be initialized as a 0 value. Now what this means is that, for example, for boolean values, this means that it starts at false. For strings, it starts as an empty string, and for numbers, so for integers, it starts as 0. So what this essentially means is that we do not have a nil value. So because of that, and because we want to be able to, when updating a task body, handle nil value. So if someone passes, for example, let's say the name, but doesn't pass the done value, so we want to update the name but keep the done value like it is. If we didn't go ahead and create this like it is right here, what would happen is that we would initialize this, let's say this struct, with the name of, let's say, a new task, wash the dishes, for example. And if the person didn't go ahead and pass this in here, we would initialize this as false, and we would essentially have any way of knowing if the person sent to us, so if the request sent to our application a value or not. And we want to be able to tell that if it is nil, if it is existent or not. So with that in mind, let's go ahead and continue. So we now go ahead and create here the function that is going to update our tasks. So let's go ahead and type in here func update task, and again this is going to be the response writer, and then this is going to be a pointer to the request. And now inside of here, let's do something similar to what we did up there. So we type in here if there's an error with decoding the body, and let's decode this into here the body variable. If the error is different than nil, we can simply go ahead, let's go ahead and copy this, and in here there was an error decoding body into struct. Alright, so now let's continue, because this is essentially everything that we did before. So os.open, then JSON file path, then let's go ahead and also handle this error, and then if this error exists, we're going to define this as error reading tasks JSON file. Okay, And now let's go ahead and also decode our tasks. So again, first of all, let's create here a list of tasks. Then let's go ahead and decode it. So if, again, same thing, if the JSON file, and then we want to decode into here our tasks, and if this error is different than nil, we want to go ahead and again simply paste this in here. And here there was an error decoding JSON file again into struct. Okay, so now we can go ahead and continue. So let's go ahead and create the part of the code that's different from the create tasks function. And what we essentially need to do is we need to start by first of all reading our task ID. Now this in here inside of the router, and you're going to see this in just a minute. This is going to be passed as such, like let's say task ID. So we're going to pass this like this inside of our path. So this is going to be tasks / task ID. So we can then know exactly what task we want to update inside of our JSON file. And the way that we read this and our router helps us with this is we simply need to go ahead and first of all, let's transform this from a string to an integer. So let's essentially do this. So this, what this makes, let's just save. So this imports, so make sure that you import here strconv. So this essentially converts strings to different kind of things back and forth. And then this essentially is the equivalent to parsing an integer. So what this essentially does is that it transforms this into an integer. And the reason for that is because here our router is going to handle here this param. So let's go ahead and pass this in here, and it is going to return to us. And we also need to go ahead and import. So again, let's go ahead and go over. We need to import both of these things. And in here, this method is going to return, as you can see, a string. And because of that, we also need to parse this into an integer. So now let's go ahead and handle this error. So we want to now go ahead and do this. And then we had an error in here converting task ID from string into integer. Okay, let's make it like this so it is a little bit more clear. And now, as you can see, we now have our task ID ready for us to use. And now let's do the following. Let's create in here a let's loop over here the range of tasks. So in here we're going to essentially this is a for loop. You can think of it like that. So we're essentially going to loop over here this range of tasks, and then here we're going to pass in here the index of the current iteration, and then we're also going to pass the current task. Now if the task.id equals task ID, so what this essentially means is that if we found inside of any one of these iterations an ID that matches, so we essentially in here is the code that we want to essentially update the task that the person is sending us. In here we simply want to go ahead and type if body.name is different than nil, and again this is a pointer to a string, not simply a string, so because of that we can check for nil value. We want to update the task.name to body.name, and if there's a body.done, we want the task.done to also be of body.done. Okay, so now essentially this is the code that we need in order to make sure that we update this. And now let's go ahead and also update it on the index. So tasks at the index that we have here currently on inside of this list is going to be of type task. Is going to have a new value of task actually. So now what this essentially means is that we've went ahead, iterated over the entire list of tasks and updated accordingly if the ID matches. Now let's go ahead and do just like before. We're going to marshal here our tasks. If the error is different than nil, we're simply going to go ahead and error marshalling tasks. And now we want to go ahead and write our new file. So essentially we're now converting our tasks into a JSON, into a byte that essentially is a JSON. So now we want to go ahead and write this in here. So the permissions also, and let's go ahead and handle this error. And this is going to be similar to this one. So let's simply go ahead and copy this one. And again, there was an error in this case writing test.json file. So in case the file, I don't know, if any kind of error occurs, usually let's just take a look at here. It doesn't say, but if any kind of error occurs while we are trying to write this file, then this is going to be returned over here. And finally, let's go ahead and type in here status OK. So now we have everything that we need in order to create, to actually update a task. So now if we go ahead and actually let's go back here to our router, and we want to now be able to update. Now usually the method that people use when updating is going to be patch. And then in here we want to pass the task ID, and the method, the function is going to be update task. And now let's go ahead, start the server. And if let's say that we have here let's take a peek in here, finish this tutorial, finish another tutorial. Let's say that instead of finishing another tutorial, which is the task of ID 6, you want to go ahead and let's say go to bed. You simply, okay, so the method is not allowed because we need to actually change this to patch. And now as you can see, we get back 200 OK code. And if we go back here to our tasks file, as you can see, we now have in here go to bed instead of finishing another tutorial. And finally, let's go ahead and delete a task by its ID. Now in this case, we don't need any type of struct because we simply need to pass in the ID. So with that in mind, let's go ahead and write in here func delete task. Again, this is going to be response writer, and this is going to be a pointer to the request actually. And then in here again, let's go ahead, decode this. First of all, actually, let's start by opening the file, which is the first thing that we need. We actually need to know what we are handling. And then if the error is different than nil, let's simply move back here, because I think we have in here a similar error. So I don't have to type this again. This actually has a typo in here, so let's correct both of them so that the error is clear. And then let's go ahead, tasks, which is going to again be a list of tasks. If the error, so the JSON file, decode into tasks, if the error is different than nil, let's go ahead and say that there was an error decoding JSON file into struct. And now let's go ahead and do everything that we need in order to delete this task from our file. Now, the thing that we need is essentially to, first of all, we need the previous length of our tasks. Well, let's go ahead and do the following. So the previous length is going to be length tasks. So we're essentially going to grab the length of the task at this point in our code. And then we also want to go ahead and do similarly to the previous update task function. We want to go ahead and grab in here our task ID and also transform it into an integer. So let's go ahead and copy this error because it is similar to this one. And now with this done, let's go ahead and do the following. We want to first of all iterate again over our tasks. So this is tasks, and in here inside of this loop, if we find a task.id with this ID, we're going to go ahead and do the following. So in here again, this block matches, so it essentially means that we found the ID that we are looking for. And if this matches, we want to do the following. First of all, let's do this, and then we want to i+1 and then spread this. So what this essentially means is that we are going to go ahead, find the tasks. We're going to go ahead and essentially remove. This essentially is the same as slicing inside of JavaScript. So if you're familiar with JavaScript, what we are essentially going to do is, let's go ahead and just draw like this because it is simpler. So what we are essentially going to do is we are essentially going to, let's say that we have here a value, and another value. We want to essentially delete this from the list and then return a new value in here. So now with this done, so essentially we now have in here a new tasks value that we essentially pulled the task from. And now we want to go ahead and type in here the current length, which is tasks. So again, this is the previous length and this is the current length. And if the current length is equal to the previous length, and here's exactly what I mean by this. So we first want to go ahead and grab here our previous length. So let's say that we have, for example, 5 different tasks, and we then want to have in here the current length after we make this entire operation. Now, if we start, let's say, with 5 and we end up with 5, this essentially means that this was not found. But if we start with 5 and then we have 4, this means that this was found. So the reason we are doing this is essentially so we can, let's go ahead and do that. We want to go ahead and return in here a status not found, and then we want to return. So at this point, we essentially, if we didn't find any kind of task by the ID, we're going to simply return this 404 error. And now let's move back here. I actually forgot to add in here the R, so we need to always, each time that we pass here to this URL param method, we need to also pass a pointer to the request. So make sure that you don't forget this thing right over here before we pass in the task ID. And now finally, let's go ahead and do the same thing, which is going to be json.marshal. So we want to marshal this. Then if error is different than nil, we want to return, and finally we want to write the file. So the path is going to be again the JSON file path, then the value is going to be, the data actually is going to be J. And now let's go ahead and copy this error because it is essentially again the same one. And finally we can go ahead and do this. So status OK. So now we finally need to go ahead, move here back to our router, so the main function in here, and tasks task ID is going to be of delete task. So now let's go ahead, restart here our router. Let's go back to Insomnia, so you can use again any kind of client you want. You can even use curl, which is simpler. And now let's take a look at this. Let's see if this works. So let's say that we for some reason don't want to go to bed anymore. We want to delete this one. Okay, and now this is deleted. And now also let's go ahead and try, for example, to slice something from here. So we want to essentially delete, let's say, walk the dog. As you can see, we now have here just ID1 and then ID3. So this is again everything that we need in order to make sure that we can create, update, and then delete the tasks, and also read the entire list of our tasks. Now, I was planning on doing both parts, so the Golang part and the Svelte part, but because I want more in depth into each part of this process, so everything, I tried to explain it more meticulously. And also let me know in the comments if you like this more this way, or if you want to simply, for me to simply go over everything, like more, let's say, more of the ideas or what's happening and not so much the details. But because this actually became a bit longer than I was expecting, I'm actually going to release in just a couple of days, in the next video, the Svelte part, which is going to essentially be us connecting a Svelte application, a Svelte front-end application, to this backend, so we can again go ahead, create, delete, update, and also read all of our tasks, so we can have a very cool looking application, to-do list application, that is also very, very snappy and that works very, very fast. And here's what I mean by that. Let's say that we want to, for example, delete a task. As you can see here, the response came back in just 2 milliseconds, and that is very, very fast. If we want to, for example, let's create again the task of go to bed, and as you can see, this was created in 1.14 milliseconds. If we create a different one, wake up, so as you can see again, 1.82 milliseconds, and that is very, very fast. And that is the reason why I believe that Golang is one of the best languages for you to build backends, because again, this allows you to essentially not only write simple code that is very, very easy to read. Again, this is very verbose, it is very specific, everything that we're doing, but it is very easy for the next person, or even you, after a couple of months of going back to the project or to a file or to part of your application, to simply go in there, read everything that you need, and know exactly what's happening. So there's no magic in here, and usually people, like I said at the beginning of this video, a lot of people like magic, they like things being done for them, but I think that if you want to be good at web development, you actually need to make sure that you build everything yourself and you understand what's happening. So again, I'm going here on a rant, but this is why I really like Golang. So again, next video, I'm going to do Svelte, the Svelte part, the client. And with that being said, let me know what you think of this video in the comments below. Also, like the video, subscribe to get notified of future content, and thank you for watching this video.